Hi, hello everyone. My name is Aaron Standard, and I wanted to talk to you about a monitoring project we've been working on for Akka.net that is now available for all people who want to buy a subscription to Phobos, which is our commercial add-on for being able to do OpenTelemetry for Akka.net. So to give you a little bit of context, this is SDK bin. I'm logged into my personal account on here right now, and we recently deployed our very first Akka.net cluster into SDK bin. If I jump over here, this is the brand new dashboard we have for doing cluster monitoring. Now, we have plans for doing a whole bunch of different things with Akka.net inside of SDK bin. It's historically been a bit of a CRUD service is how it's worked. We're going to make it much more event-driven, and we're planning on adding a lot more workflows for things like customer communication, onboarding, activation, billing, all that sort of stuff. But the big story here is the dashboards. So we have had a version of this dashboard for some time. This is our Akka.Cluster dashboard that shows you the shape of our cluster. Now, a couple of the big things that we've done is we have retooled it so it uses all of the OpenTelemetry sort of standard metadata pieces now for being able to allow us to filter data about our Akka.net application. So in this case, if I look here, all of these different environments and services are all running inside their own separate namespaces inside a Kubernetes cluster that we manage. We have our development environment, production environment, QA environment, and they're all running on essentially the exact same Kubernetes cluster, just with different namespaces, different domains, and possibly different node counts. So this is what we've got going on in terms of SDK bin's production environment. I can go ahead and filter this down to, let's say, just the NuGet service if I want to. So the cluster size is still 8. The reason being is that the 4 nodes from the user service are also still a part of it. But these are the nodes that really have our actor workloads today. The only thing that we're really using Akka.net for so far is keeping track of product usage, which customers are installing which versions of which packages and when do they do it, that type of thing. So let me go ahead and add that back. You can go ahead and filter by instance if you want to. You can filter by the type of actor you want to see data for. So if I scroll down here, for instance, and expand this, I can see our logging and error rates. Looks like we've had some disassociation exceptions, some aggregate exceptions, and so forth. This is probably all database-related work. None really within the past 30 minutes. If I go and broaden this out to the last 24 hours, you can go ahead and see different periods of stuff getting logged. This is probably all when people are downloading stuff inside SDK bin here. And you can also see on the little spark lines right here, a little burst of activity happening kind of intermittently throughout this 24-hour period. SDK bin tends to be very bursty. People will go and restore a whole bunch of packages, will get hit with a big wave of traffic all at once, and then it will subside. That's just kind of the nature of how the service works. We probably handle about 250,000 requests per day. Not a huge number. Services like Marked Up, which I've written about in the past, we were handling closer to like 500 million requests per day there. So we've had a lot of experience with different applications of different sizes here. SDK bin is still on the small end of things. But I'm able to get really useful data out of this dashboard here. One of the other things that we've added recently is the ability to segregate your metrics based off whether they're coming from system actors. These are actors built into Akka.net itself, or user actors. These are actors you created as part of your application. The reason why we did this is that system actors can sometimes crowd out your user-defined actors. So if you want to go ahead and just get rid of them off the chart, you can go down to actor types here and just select user. And that will allow you to go ahead and filter them out, or you can do all, which will include both types of actors. So if I scroll down here, this is another very interesting chart that we've just added back in the most recent version of Phobos. This is a favorite metric that we had from before Phobos supported OpenTelemetry, back when we were using OpenTracing and App Metrics, which was the Mailbox backlog. This metric allows you to keep track of how many unprocessed messages are sitting inside an actor's mailbox at any given time. If this value starts to creep up, it means you're starting to experience back pressure inside your system, and that means that there's going to start being some processing delays. Now here you can see that the average backlog size is like less than a message. That means that when we were taking these samples across all of these nodes, there might have been some nodes, there's 8 total we're monitoring the cluster, that had a back pressure of 1, meaning 1 unprocessed message at the time we took that gauge reading, but it eventually cleared. If you see this number creeping up into a value greater than 1, you're probably starting to experience some real back pressure inside the system here. So this allows you to go and measure it. Only the newest versions of Phobos will allow you to keep track of this, which I believe, if I go to the Phobos website, which I believe is, let's see, version 2.10. is the most recent version you want to go ahead and install. This will give you access to this data and will make this chart actually render correctly for you in Grafana. Next, we have this chart down here, total number of actors. That's pretty straightforward. Kind of just helps you plot the total number of actors across each node here. We have total throughput divided by system and user throughput. And then finally down here, we have the ability to filter message totals. So how many messages have been processed by type? What's the processing type down here? And also, what are the population distributions of live actors looking like? Well, right now it's mostly shards inside the system because we don't have that many entities active at the moment due to the fact that we probably don't have anyone actively hitting the NuGet feed. And if I drop this down to just user-defined actors and scroll down, all of a sudden this chart will completely recalculate. And instead of seeing shards and a bunch of sharding traffic, you'll go ahead and see all of the live tracking actors right now. So we have this actor that looks for overdue accounts, and these actors that send templated messages, and this actor that keeps track of package downloads. And none of them have done that much work over the past 24 hours on average. This is sort of what the cluster dashboard looks like. And I guess the last thing I should look at is we do have a detailed breakdown of where Akka.Cluster.Sharded entities are distributed at any given point in time. So you can see here that we have about 40 shards inside the system. That's how many are configured, and they're spread evenly across all 4 of our NuGet service nodes. And right now, there are no entities active at any of the nodes. That's because we don't have any traffic right now. We don't have remember entities turned on, and entity actors always get passivated automatically after, I think, 60 seconds of inactivity by default. So this is the sharding dashboard, which is super useful. The next dashboard I wanted to take a look at, and this is a brand new one that we've completely built from scratch, is our Akka.NET Performance Analysis Dashboard. This is designed to drill into the performance of a specific actor and try to understand how well it's working at any given point in time. So this has the same sort of filtering the cluster dashboard does, but the big difference here is that we're not trying to understand sort of how the application as a whole is performing necessarily. What we're really trying to do is drill into a specific actor type and understand how long does it take to process a message, what distribution of messages does it typically process, what are the latency distributions, and we can also do backlog, crash, and error analysis as well. The other thing you can see down here is that we can keep track of how many unhandled messages or dead letters has this actor emitted over this time period. And right now we can see that it's 0. This actor typically does not have dead letters or unhandled messages because it's been programmed appropriately. But we've actually used this dashboard to solve some bugs, in particular with some of the actors responsible for doing transactional emails in the system. You can see that the distribution of messages here is all concentrated around a single message type. That makes sense. Well, if I want to go and restructure this a little bit, let me flip over to doing both system and user-defined actors. And let's pull up the cluster shard actor right here. I can see there's 40 of them. Over the past 24 hours, they've done 409,000 messages, average of about 5 per second. And I can see the distribution of messages that they've all processed right here, along with little spikes in their latency when they are beginning to do work. If I scroll down a little bit further, I can take a look at their average backlog, and the average backlog size for these shards is all 0. So they're able to process messages pretty quickly by the looks of it. So in the grand scheme of things, these dashboards are meant to be really easy and trivial to understand, but they do require you to go ahead and get them installed inside your application. Okay, so the next thing I wanted to show you is how to actually install the dashboards into your Grafana instance. Now, these dashboards are built to work with Prometheus plus Grafana. This is sort of the lingua franca of all OpenTelemetry monitoring in most ecosystems. Now, if you're using something different like Azure Monitor, for instance, there is a Prometheus adapter for that. We have customers using these dashboards with it. It will work. I'm almost certain there's ones for Datadog, Elastic, and other APM vendors too. Please go and take a look at it. We wanted to consolidate down the number of dashboards we maintain to just these 2 really strong reference ones and not try to support like 5 different APM vendors to do it. So we use Prometheus and Grafana. And there's a lot of adapters for PromQL, which is the Prometheus query language. You should look that up and use it. Now, to get these dashboards into your Grafana instance, to scroll down on this page here, you can either view the repository, which has the raw JSON for defining these dashboards in it. You can customize that to your heart's content. Or you can go to Grafana Cloud and grab. So I've got one for the cluster metrics, the other one for the performance analysis. You can go ahead and basically copy the dashboard ID here. Go over to one of your Grafana instances. So let's go to this one. We'll go to dashboards. We'll go and do import. I'll paste in the dashboard ID, press load. we'll get a complaint because we've actually already imported this exact dashboard from Grafana Cloud already. I can go ahead and give it a new identifier, select my data source, press import, and voila, it is up and running instantly. It is very, very easy to get up and running with these dashboards. Now, we're going to do a longer video on this, our Phobos Quick Start tutorial. It exists inside this repository here. You can also see a preview of what all the resources look like down below. After you've bought Phobos, and if you want to try to get it up and running quickly and kind of understand how it works, the Quick Start tutorial is the place to do it. Basically, what I want to show is what you actually need to do to get Phobos installed into your system. First, you need to add the NuGet feed that SDKBin will give you after you've purchased Phobos. You need to go ahead and add that to your NuGet.config. That's the first thing you need to do. Next thing you need to do after that is if I go to the source and I go to the Phobos.web project and I go to the C# project here, you want to add a reference to Phobos.hosting. This is our meta package for Phobos that also references Akka hosting. So it should just plug right in to your existing application. And then you want to go to program.cs. We're going to scroll down a little bit. We're going to go ahead and take a look at where we're configuring OpenTelemetry. And on the tracing builder, you call add Phobos instrumentation. This will enable Phobos tracing. You want to go to the metrics builder, do the same thing. That enables Phobos metrics. And then where you configure your actor system, you want to go ahead and call with Phobos Akka run mode Akka.Cluster. This will inject Phobos telemetry using the appropriate actor reference provider. In this case, we're using the cluster actor ref provider. We also have one that does only Akka.remote and another one that does only local Akka. Kind of depends on what you need for your application. But this will make sure all the telemetry is being injected inside your applications. So thank you for watching. We'll do some more videos that get into some more detail on Phobos performance tuning and tracing and all that good stuff. But for now, we just wanted to show you the dashboards and help you get your feet wet with those. Please go ahead and use them if you're a current Phobos user. And if you're not a Phobos user, consider going to the buy page here and contacting us about a demo or about maybe purchasing via purchase order, or pay right now with a credit card and get access to it today. So thank you very much. We appreciate your business. Every single customer who buys a Phobos license effectively supports and funds the development of Akka.net. Thank you. Well, that'll do it for this video. If you found this video useful, please don't forget to check the description to find links to other resources we may have included. So blog posts, GitHub code samples, other videos, so on. And as always, don't forget to like and subscribe and ring the bell for notifications. We'll catch you next time. Thank you very much.